So this slide here describes what some of the key features and FutureGrid in the cloud area. It doesn't describe the HPC. So actually an important difference is, which is the second point, is that FutureGrid is more than the cloud because it supports cloud grids and high-performance computing. But one important difference between, say, Amazon and Azure and FutureGrid is very transparent. You know what node you're using. You can get the same node again, so you can do reproducible experiments for both functionality and performance testing. And as I've already mentioned before, you can actually get the same node with and without a virtual machine. FutureGrid, unlike most commercial systems, it supports 3 different virtual machine managers. And we have, if we sum over the projects on FutureGrid, we've actually run 5 different virtual machine managers: Nimbus, Eucalyptus, OpenStack, CloudStack, and OpenNebula on FutureGrid. OpenNebula actually we use to manage our approach for the RAIN system. And we're not tending to do just production. We do research on tools and middleware and systems, as well as some modest amount of science production. And another key feature of FutureGrid, which I've already described, is we developed quite a bit of middleware. FutureGrid supported a lot of the Nimbus development because when FutureGrid started, OpenStack essentially didn't exist, and Eucalyptus was a bit laggardly in coming out with new releases, as it had both an open source and a commercial side, and the commercial side was dominant for a while. And of course, we have substantial experience in running cloud systems. So here, this slide here explores certain features of FutureGrid, which could be interesting to people. The one aspect of FutureGrid is it is an on-ramp to other systems. So what does an on-ramp mean? You can start on FutureGrid and go elsewhere. So you can do, as we've said, the education and training for all systems on FutureGrid. And after you've been educated or trained, you can actually do all your work on FutureGrid. That's what many of our projects do. You can download appliances and use systems like VirtualBox to run on a local machine. Or you can use our component cloud mesh of RAIN to jump to a chosen production system. Cloud mesh is still under development and will be released with the rest of RAIN at the end near the end of the summer. And it's built in terms of with Python, with various Python libraries, and it effectively controls RAIN and allows you to instantiate either on FutureGrid or on other systems such as Amazon. The images are defined templated, so the same template can be redirected to Azure, Amazon, Eucalyptus, OpenStack, etc. And it can provisions not just a single image, but the complete system needed by the user, and it deploys your full range of software. An important aspect of what we've been doing as part of FutureGrid and also Exceed funding is to build a set of metrics, because virtual machines are just different from non-virtual machines. And so a lot of the tools, for instance, developed for Exceed needed to be extended to be able to monitor what virtual machines are doing. And we have spent a lot of effort trying to make certain our monitoring is extensible and compatible with what Exceed uses for its classic HPC environments. People always ask about security and what are the security issues with FutureGrid. So of course we support cybersecurity research. I gave you an example of that privacy preserving Hadoop earlier in the talk, and we would love more security proposals on FutureGrid. If you look at the operation of FutureGrid itself, the security falls into 2 areas. There's the actual authentication or authorization model. That's actually pretty tiresome because it's just different. And we cannot use directly the same model used in Exceed because that just doesn't support the current virtual machine managers. Thus, the different virtual machines actually change. The latest release of OpenStack Grizzly is not compatible with, well, it's extended from the previous versions of OpenStack. So we try to isolate users from these changes. We have to worry about defaults being set on the systems, which are not these open source systems, which are just not secure. And we have to cope with these, say, the difference between the VM approaches and the classic HPC approaches. We do this with a distributed LDAP environment, and that we will synchronize via the so-called AMI system with that on Exceed, so you can use Exceed credentials on FutureGrid. The latest version of OpenStack is attractive to us because it's redone a role-based access control mechanism, and it's got a better, in our opinion, a better approach, which is more compatible with those used on commercial clouds. The final part of security on FutureGrid is the actual dynamically provisioned images. And we need to be very, obviously, if you dynamically provision images, you have to be pretty careful you're not dynamically provisioning a rogue image. And we do that, we test that in several ways. The templated image generation automatically puts security restrictions into the image. It removes root access. It checks that you have the latest bug fixes in. And it also has restrictions on what type of users can actually use these images. And so we explicitly vet the images before we allow bare metal deployment. So we don't store any SSH keys in the images. We just call this the identity service, so only certified users can actually use the images. And we have extensive effort to actually certify users through the portal when they log in. The next slides describe related projects. We have the project that's nearest our work is called Grid 5000 in Europe. And there is also a project called OpenCirrus in the US, which have sort of somewhat similar environments to FutureGrid with managed virtual machine-based environments. And we collaborate with both those systems. Planet Lab is very well known and important environment, has a stronger network focus, and their system is less managed, so less reproducible. Genie has many related activities, including the network-centric systems Emulab. Probe is a new environment, and there is ProtoGenie, ExoGenie, InstaGenie, and Genie Cloud, all of which are related to FutureGrid in that they're using software-defined environments based on the network focus of Genie. Bonfire is a system in Europe similar to Emulab, and the EGI has a federated cloud with OpenStack and OpenNebula, which is aimed at building on the European grid integration to build a European cloud federation. There are, across the world, and especially in the US, several private clouds. There's the Red Cloud at Cornell, which is part of Exceed, Wispy at Purdue, which is part of Exceed, Open Science Data Cloud, and Open Cloud Consortium. These are all cloud environments which tend to have more of a science cloud or a research cloud focus of actually supporting production cloud use, whereas Grid 5000, FutureGrid, OpenCirrus are aimed at experimentation. They're testbed as a service. And as we already said, public clouds such as Amazon are incredibly important and hugely successful, but they don't clearly support the same reproducible experiments and the same bare metal and virtual machine comparisons that FutureGrid does. Plus, you cannot actually experiment on the low-level cloud technology because that's prescribed for you by Amazon, Google, and Microsoft. That's for the three major big vendors in this field.